Hey guys, we have a problem here that is a sinusoidal wave which has a wavelength of 35 centimeters and an amplitude of 20 meters, and it says that is going to the left, so the velocity goes to the left, and says that at time 0 and at time x equals 0, y is equal minus 3. So let's start graphing that. So if this graph has a sine form, we might start from 0 and then start to do like the wave, and it says that it's going to the left, so the velocity is going to the left, and this is the amplitude of 20 centimeters. And also the problem is saying us that the graph at point x0, y is minus 3. So this graph is not starting like in 0, it's like starting like in minus 3, 0, comma minus 3. So it's a little bit displaced to the right. And also it's giving us a wavelength that it goes from a valley to a valley. So here we have the first valley that's going to the second valley, and that's a complete wavelength. Now in the second question, it is asking us for the wave number, the period, the angular frequency, and the wave of speed. So first let's calculate the wave number, and we know that the wave number is 2 pi over lambda, which is the wavelength, and we already have those values, so we only have to substitute those values. And remember that you have to convert those centimeters into meters, so you'll get a result of 17.29 radians per meter. That is also 47 times pi. Now for the period, you only have to know the equation for the period, which is 1 over the frequency, and we already have the frequency, which is of 12 Hertz. And you only have to substitute that. And while 12 is more or less 0.083 seconds. For solving the angular frequency, we know that omega equals to 2 pi times the frequency. So you only have to substitute those values and you'll get like 24 pi, or that is equal to 70.4 radians per second. Now we have to solve the speed of the waves, which the formula for this is lambda, the wavelength, times the frequency. And you also have to take into account to convert the 35 centimeters into meters, which will give you 0.35 meters. And now you only have to substitute those values in the equation. Remember that 1 Hertz is equal to 1 over the seconds, and that will give you 4.2 meters per second. Now the problem is asking us for an expression for the wave function. So we have to remember that it's a sine function. So y of x of t is equal to the amplitude times the sine of wave number times x plus the angular frequency times the time plus the phase angle. We know the values of all the variables, the amplitude, everything, but the only missing thing is the phase angle. So we only have to recall that in the problem is saying us that at y equals minus 3, x equals 0, and t equals 0. So we only have to evaluate the function in those terms. And now the only thing that we got is that y equals minus 3 and the amplitude is the 20 centimeters. So we have to convert that into meters, which is 2 meters. And we only have to isolate the phase angle in order to get that variable and finally get our wave expression of the wave. And you also have to remember to convert those centimeters into meters. Those are meters, 0.03 meters, and we'll get the phase angle. Now we only have to substitute the values of the constants of k, of omega, and of the phase angle in our equation, and we'll get the function of our wave.